Have you ever looked up at the sun and wondered if something much bigger exists? Not just a little bigger, not twice its size, but so unimaginably massive that if it replaced our sun, the planets we call home would simply disappear inside it. Earth, gone. Mars, gone. Even the orbit of Jupiter wouldn't feel safe. It sounds like science fiction. But it's real. Out there, hidden among billions of stars, astronomers have discovered a cosmic giant so enormous that our brains struggle to comprehend its true size. A star so vast that comparing it to our sun is like comparing a grain of sand to a mountain. And the most terrifying part, this isn't the biggest object in the universe, because it's dead. It's alive. Every second, unimaginable nuclear reactions rage inside it, releasing more energy than humanity could ever produce in millions of years. Its surface boils with colossal storms larger than entire solar systems, while rivers of superheated plasma erupt into space. Trying to understand its size is almost impossible. If our sun were shrunk to the size of a basketball, Earth would become a tiny grain of pepper several meters away. Now imagine placing that basketball beside a star so enormous that the comparison itself almost loses meaning. This isn't just another star. It's one of the largest ever discovered by humanity. A true cosmic monster. But here's the question that keeps astronomers fascinated. How can something this impossibly large even exist? And what happens when a star this enormous finally reaches the end of its life? That answer is far more terrifying than the star itself. Before we can understand how a star becomes this unimaginably large, we have to go back to where every star begins. Not in light, but in darkness. Scattered across our galaxy are enormous clouds of gas and dust called stellar nurseries. They appear calm from a distance, but inside them, gravity is quietly pulling billions upon billions of tiny particles together. Over millions of years, that invisible force squeezes matter tighter and tighter until something extraordinary happens. The temperature rises to millions of degrees. Pressure becomes almost unimaginable. And then, a spark. Deep inside the collapsing cloud, hydrogen atoms begin fusing into helium. For the very first time, a new star ignites. From that moment on, an invisible battle begins. Gravity is constantly trying to crush the star inward, while nuclear fusion pushes outward with unimaginable force. These two titanic powers remain locked in a perfect balance for millions or even billions of years. Our own sun has survived this cosmic tug-of-war for over 4.6 billion years. But not every star follows the same path. Some are born with far more mass than the sun. They burn hotter, brighter, and far faster. Instead of living for billions of years, these giants race through their lives, consuming their nuclear fuel at an astonishing rate. And the more massive a star becomes, the stranger its fate. Because the universe has a habit of rewarding greatness with one of the most violent endings imaginable. Next, we'll meet the colossal giant that pushed the limits of what astronomers thought a star could become. So, what is this cosmic giant? Meet Stephenson 218. Hidden nearly 20,000 light-years from Earth, deep within the constellation Scutum, this red hypergiant is one of the largest stars ever identified by astronomers. Its true size is almost impossible to picture because nothing in our everyday lives comes close. Our sun measures about 1.39 million kilometers across. Stephenson 218 is estimated to have a radius around 2,150 times larger than the Sun's. If you could somehow place it where our Sun is today, the result would be almost beyond imagination. Mercury would vanish. Venus would disappear. Earth would never have existed. Mars would be consumed. Even Jupiter's orbit would lie deep inside its swollen atmosphere, and the star's outer layers could extend toward the orbit of Saturn. To fly around Earth's equator in a commercial jet takes less than 2 days. To circle Stephenson 218 at that same speed would take hundreds of years. Yet despite its unimaginable size, this giant is surprisingly fragile. Its outer atmosphere is so thin that, compared to Earth's atmosphere, it resembles an almost perfect vacuum. It is less like a solid sphere and more like a vast ocean of glowing gas, constantly expanding, contracting, and shedding enormous amounts of material into space. And that's exactly what makes astronomers uneasy. Because a star that grows this large isn't becoming stronger, it's approaching the final and most violent chapter of its existence. In the next phase, we'll discover why stars this enormous are living on borrowed time. The larger a star becomes, the more unstable its existence. Stephenson 218 may look like an immortal giant, but in reality, it's fighting a battle it cannot win. Unlike our Sun, which burns its fuel slowly over billions of years, a red hypergiant lives fast. Its enormous mass creates crushing pressure in its core, forcing nuclear fusion to occur at an incredible rate. Every second, it consumes unimaginable amounts of hydrogen, releasing energy on a scale beyond human comprehension. But eventually, the hydrogen begins to run out. To survive, the star starts fusing heavier elements helium, then carbon, neon, oxygen, and silicon. Each new stage burns faster than the last. What once took millions of years is reduced to centuries, then years, and finally, mere days. Meanwhile, the star's outer layers become increasingly unstable. Powerful stellar winds blast billions of tons of superheated gas into space every single second. Vast shells of glowing plasma drift away, forming enormous clouds that stretch across trillions of kilometers. In a sense, the star is slowly tearing itself apart. Astronomers have observed these violent outflows around many red hypergiants, revealing that the biggest stars in the universe are constantly shedding pieces of themselves long before they die. And at the very center, something even more dramatic is unfolding. An invisible clock is ticking. Because once the core begins producing iron, everything changes. Fusion, the force that has held the star up for millions of years, can no longer save it. When that moment arrives, the collapse is no longer a possibility. It's inevitable. And in the next phase, we'll witness one of the most violent explosions the universe has ever created. Then, it happens. The iron core can no longer support the crushing weight above it. In less than a second, gravity wins. The core collapses inward at an astonishing speed, reaching temperatures of billions of degrees. Matter is compressed so violently that atoms are ripped apart. Electrons and protons are forced together, forming an ultra-dense core, while an enormous flood of tiny particles called neutrinos erupts outward. For a brief instant, the collapsing core rebounds like a compressed spring. That rebound, amplified by the escaping neutrinos, launches a shockwave racing through the star at millions of kilometers per hour. When the shockwave reaches the surface, the star explodes. A supernova. For a few weeks, A single dying star can shine brighter than an entire galaxy containing hundreds of billions of stars. In those final moments, the explosion forges many of the heavy elements that make up planets and even our own bodies. The iron in your blood and the calcium in your bones were born in ancient stellar explosions like these. But beauty hides a terrifying reality, because the expanding fireball is only the beginning. The deadliest part of a supernova doesn't always come from the explosion you can see. It comes from the invisible radiation racing ahead of it at the speed of light. Imagine witnessing that supernova from a nearby planet. You wouldn't hear the explosion. Space is silent. Instead, the first sign would arrive as an invisible storm moving at the speed of light. Long before the expanding fireball reached you, an intense burst of gamma rays and X-rays would sweep across your world. These are the most energetic forms of radiation in the universe, carrying enough power to shatter molecules and tear apart the chemistry that makes life possible. If a massive star exploded close enough, Earth's atmosphere could suffer catastrophic damage. The protective ozone layer could be severely depleted, exposing the surface to dangerous levels of ultraviolet radiation from the sun. Scientists have even explored whether nearby supernovae may have influenced Earth's history in the distant past. Fortunately, there's reassuring news. Stephenson 218 is located nearly 20,000 light-years away. Even if it exploded tomorrow, its radiation would be far too distant to threaten our planet. Distance, in the universe, is often the difference between annihilation and complete safety. But that raises a more unsettling question. If this giant is harmless because it's so far away, could there be another massive star much closer to Earth, one that astronomers are already watching? The answer lies in a familiar star that has fascinated humanity for centuries. That star is Betelgeuse. Visible to the naked eye in the constellation Orion, Betelgeuse has fascinated skywatchers for centuries. Unlike Stephenson 218, it's much closer to Earth, about 550 light-years away, and it's also a red supergiant nearing the end of its life. In late 2019, something extraordinary happened. Betelgeuse suddenly faded so dramatically that astronomers around the world wondered if they were about to witness a supernova within their lifetime. The event became known as the Great Dimming. Telescopes turned toward Orion. Observatories rushed to collect data. For months, no one knew exactly what they were seeing. Had the countdown to a stellar explosion finally begun? The answer turned out to be just as fascinating. Scientists later concluded that Betelgeuse had expelled a massive cloud of gas from its surface. As that gas cooled, it condensed into enormous clouds of dust that temporarily blocked part of the star's light from our point of view. It wasn't dying that night, it was shedding part of itself. Even so, Betelgeuse will explode someday. It could happen in 100,000 years, or tomorrow. Astronomically speaking, that's an incredibly short window, but for humans, it offers no way to predict the exact moment. And when it finally happens, humanity will witness one of the greatest celestial spectacles in recorded history. Phase 8. When we look at stars like Stephenson 218 and Betelgeuse, it's easy to feel small. But perhaps that's the wrong way to see it. These giants are not simply destroyers. They are creators. Long before Earth existed, generations of massive stars lived, died, and exploded across our galaxy. Each supernova scattered newly forged elements into space: carbon, oxygen, iron, calcium, gold. Uranium ingredients that would one day become planets, oceans, mountains, and life itself. Over billions of years, gravity gathered that ancient stardust into new solar systems. One of them became ours. Every breath you take contains atoms born inside long-dead stars. The calcium strengthening your bones, the iron flowing through your blood. Even the oxygen surrounding you all began their journey in stellar furnaces billions of years ago. In a very real sense, the universe became conscious enough to look back at itself. Today, humanity points telescopes toward these distant giants, not because we fear them, but because they tell us where we came from and perhaps where we're going. The largest stars remind us that even the most powerful objects in the cosmos are temporary. They shine brilliantly, they transform the universe, and then they make way for something new. So the next time you look into the night sky, remember this. The atoms inside you were forged in the hearts of ancient stars. And one day, they'll become part of the universe once again.